Hey, everybody. It is Astronomy Daily Live. You can call me Cosmic, and it must be 2 hours UTC because I am live again. So thanks for coming in. Thanks for watching. If you're viewing this live or viewing this not so live a little bit later, uh, whatever it is, welcome, welcome. Hope everybody's doing okay. Hope their day and night, their past 24 hours, one more spin on the axis of this planet that's just constantly making me dizzy. um, yeah. So hope everybody's doing well. Everything's good here. Um, oh man, I've been playing with this little problem that Tony Darnell over at Deep Astronomy posted to us the other day, and man, I don't have anything to drink. So yeah, I'm probably going to have to pause at some point, but I can go through the intro here just to. I like to do the intro for a few minutes to let everybody come in, and also for any kind of newcomers, to sort of get an idea of what this is all about. So this is just a casual, fun. Hopefully, the quality is relatively high. Um, Circle of friends who come together each day and um, talk astronomy for usually about an hour or so. Sometimes a little bit more. Sometimes we can get to rambling on and on and on. But this is also a show about science and sort of the process of science. And science starts, at least in my opinion, with sort of two fundamental practices, and that is being skeptical, and that means not throwing things away, not at all, but taking a good hard look at everything, um, and questioning things, um, all the time. But at the same time, sort of, this is sort of like a coin, right? A coin has two sides. There's a heads and there's a tails, and so there's a skeptical side. The other side is um, being open-minded. So that means being accepting of especially new things, new perspectives. Um, being just kind of open to that kind of stuff. So those are kind of two sides of the same coin. So that's what this show is about too. Is you know um, scientific um, um, uh, inquiry, um, being curious. And when I was a kid, uh, I, I was sort of like, wow, I'm sort of interested in everything. Every single thing I seem to be extremely curious about and wondering, who, what, when, where, why, all of that, right? And so when I looked around in my world, it's like, okay, what is going to allow me to sort of, look at everything? And my answer uh, um, came to me in that it's like, well, I'm going to be an astronomer because those people seem to uh, seem to be studying everything from the subatomic and what what the electrons are doing inside of atoms, absorbing light, emitting light, jumping um, jumping between um, energy levels, all of that. Wild, wild, wild stuff. Deep, 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 very, very small. to very, very small time scales, to short wavelengths, to the opposite side of that, studying the entire universe, and you know, um, all wavelengths of light and all time scales. So it seemed to me, and um, it still seems to me, that astronomy sort of deals with everything. So uh, I was hooked. I was hooked, and this is a place for um, um, similar, like-minded people, to come together, get together in sort of a virtual circle and have a chat about this thing that we are, completely passionate about. So yeah, that's what this is all about. So glad everybody's coming in. I'm going to start up my chat over here too. Let's see, how can I do that? Oh yeah, I've been dealing with this worldwide telescope thing today, so my brain is sort of scrambled. it's just a it's turning out to be sort of almost a ridiculous problem that doesn't necessarily need to be a problem if yeah, it's still sort of hard to say, but yeah, it's sort of looking like the worldwide telescope folks need to sort of um, get with it a little bit and be able to properly read in FITS images. They uh, their client software uh, claims to be able to read in FITS images, but when you try to load in a FITS image, it complains that it doesn't have um, um, AVM metadata. So it's like, oh, come on, guys, come on, let's let's do it, let's do it. So yeah, that's sort of where that is at the moment. FITS is a file format that most professional astronomers use. FITS stands for Flexible Image Transport System, and it essentially consists of two pieces. It's a single file. Hey there, Uncle Bill, Warnock 69 XXX, and Susan. Hey, hope everybody's doing good. Um, uh, So a FITS image is just a single file. It usually has the extension either .fits or .fit. Um, Technically, it can be um, um, any extension you want, but if you want to be able to glance at it and say, okay, that's a FITS file, then it's usually one of those two. And FITS files have sort of two parts, um, and it can get much more complicated than this because it has extensions and yeah, it's just it can become a mess. Um, but basically, two parts. The first part is what's called a header, and the second part is what's called the data. And the header is just metadata. So it's data that describes the data. So in the case of like an image, right, it would say the X size and the Y size of the um, um, image. Maybe it says things about, you know, when the image was taken and what kind of instrument and what the temperature was and uh, all kinds of other information, lots and lots and lots of other information. The header can be quite large, depending on what kind of information, what kind of metadata you want to store about the image that is contained in the data part. And I've got to apologize for last night. I think I was using my laptop microphone to record that. So sort of went back to the first few days of the live stream when I wasn't using this very professional mic. So yeah, you probably got a little bit of reverb and all that. It's not going it's not going to change the content of this um, live stream in any way. But I think the mic here gets rid of the reverb. It's a little cleaner, although really it's not the ideal mic for this, nor is the video here. But who cares? We're casual here, just having fun, and talking about astronomy. So who wants to look at this anyway? So who cares? Yeah. So hope everybody's doing very, very well tonight. Glad to see you all here. Um, if if you're new and haven't subscribed yet, make sure to do that. You can. I think once you do that, you can hit. I think there's like a notification bell. Looks like a bell, so you can be told. You can be notified when I go live every single day. So if you can't figure out what local time is 2 hours UTC, which is coordinated universal time, uh, then you can just set the notifications. And if you have everything set uh, um, correctly, you will be sent a notification as to when I go live. So you can do that, or you can just figure it out yourself. That's really the better way. But if you want to cheat, that's a good way too. I have no problem with that at all. So make sure to like the video, or you can also not like it. I don't really mind at this point. What I'm looking for, mathematically speaking, is the absolute value of of your response. So whether it's a positive value or a negative value, I don't care. It's a response. Um, Leave any kind of comments you want down in the comment section. That'll be great. I like to see more comments for sure, especially criticisms. Right? Let's and as as long as it's a um, constructive one, you can be as harsh as you want. I don't care, and I will try to listen, because that's what this show is all about, is being open-minded. Open-minded. So if you have a criticism, uh, or any kind of a suggestion, uh, in terms of what you want to hear about, um, or talk about it, bring it up in the chat live, or make a comment for sure. And last but not least, make sure to share this video and this channel with people who you think might be interested in this kind of topic. Um, and the format, as I said, is supposed to be sort of just laid back, casual, circle of friends getting together every single day in a virtual way, which is very, very cool, and chit-chatting about all things astronomical. So yeah, I think what I'm going to do at this point is I'm going to take a little pause, just a little pause, and get something to drown the throat. So okay, I'm going to mute this, and I will be right back. You can you can stare at the background here. Look, I'll even raise it up so you can see the 8.4-meter mirror that went into a telescope called the Large Binocular Telescope. All right, I'll be right back. Just a minute. That was kind of fun. I just watched it too. Okay. Sorry about that. I like, it's nice to have fun with these kinds of things. So, yeah, definitely tonight. Not a fresh batch, but uh, still quite nice. It is the hydrogen hydroxide tonight. HOH, hydrogen hydroxide. So cheers. Mm, yeah, but Susan, it's just like driving in a car, right? Technically speaking, technically speaking, you're not moving, right? I mean, if you were moving, you would feel it, right? So when you're driving in a car going down the interstate at, 75 or so, you can look around and notice that relative to everything else you're moving, but especially if it was super smooth and not as the driver, but if you're a passenger, right, and you close your eyes and it's super smooth, can't tell, can't tell. Plane rides um, are like that, right? You're traveling 300 or 400 miles an hour relative to the ground, but it's so smooth you can fall asleep. So yeah, it's relatively speaking, sure. We are moving in insanely dizzying, crazy ways. But mm, I don't know. I'm sort of looking around here, and it's like I doesn't. I'm not moving. I mean, you know, I'm moving a little bit, right? But all motion is relative, and whether there is sort of an absolute position, most astronomers would say no, there isn't. Newton thought that there was, and that was sort of believed for several hundred years until Einstein came around, and said, no, 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 relativity, relativity, everything is relative. So, yeah, it's really what it comes down to is a matter of perspective. So, it's fun, to think about how we are moving, relative to the center of the Earth, or relative to the sun, or relative to um, the center of the galaxy. But mm, don't sweat it too much. It's kind of nice to think about, and it's fun, to throw your perspective around, uh, and get completely dizzy and stuff, because all that is happening, right? It actually is. But relatively speaking, nah, we're not moving. Cheers. All right, well, cool. The other thing that I want to do is I want to make a slight correction to yesterday's show as well. Remember, we looked at Messier object number 71. And when I first saw that number, I got really, like, oh man, this is my second favorite object in the entire sky. And then I saw what it was. It was described in Sinbad. A little bit more. There we go. Because I'm having to stretch. I don't. I I want to relax, right? I don't want to have to work at all. So if I want to slouch a little bit, I can just turn the camera down a little bit. Um, so I was really excited, right? It's like, oh, this is um, my second favorite object in the entire sky. And then we went to Simbad, and it said that it was a globular cluster. And I remember M71 being a very, very rich open cluster. And well, this is one of those objects that is sort of right in between. So it's a very, very uh, rich um, um, open cluster, meaning that it has a lot of stars. Most open clusters, it's hard to sort of give you an average, but the average number of stars in an open cluster might be 1,000 or so, maybe. Um, and the average number of stars in a globular cluster might be 100,000. So 100 times that or so. Well, I think, and we can actually, what I should do, what I should do is, um, let's go to Burnham's Celestial Handbook and see what it says about M71 really, really quick. And then I want to do today's object of of the day. So let me grab the volume that has the constellation of Sagitta in it, which should be the third volume. So hold on one second. Okay, so as you can see, this volume of Burnham's Celestial Handbook has absolutely no cover on it at all, because I have had these books for pretty close to 40 years. And, you know, they get opened and closed and packed in things and moved around and read through and everything else. And, covers fall off. I don't think I've lost any pages though. So let's just look really, really quick at Sagitta, and we'll look for M71, which is here. Whoops. M71. Where's M71? M71. And at least according to this volume of Burnham's, so it goes through the history, when it was first discovered, et cetera, et cetera, et cetera. Does it say how many stars there are? It does not. It does not say how many stars there are. Well, I think the Sinbad thing, either Sinbad or Ned, I think was saying like 3,500. So 3,500 is still a little, not very rich as far as a globular cluster goes, but it's very, very rich in terms of what an open um, cluster is. Sinbad's calling it a globular cluster. I'm going to dispute that. I'm I'm going to say I'm going to continue to say that's a um, that it's a very, very rich open cluster. And having said that, I can be finished with this thing and say yes, for sure. That is my second favorite Messier object in the entire sky. My first favorite Messier object is M37, which is also an open cluster in the constellation um, um, Auriga. Auriga, I think, is the goat, and it's actually just north of the constellation of um, Orion. So, yeah. All right, I'm going to be done with that. What we're going to do is we're going to go do an object of the day. Now, I don't think I'm going to be doing an object of the day every single day, because we want a little bit of variety, spice of life. But let's go over to random.org. Now, maybe anybody's if anybody's in the chat, and I can actually find out if there's anybody in the chat. Oh, there's nobody in the chat. All right, well, forget it. I will choose. I think that I am going to. I'm going to do another. Let's do an NGC. Okay, let's do an NGC object tonight. So we're going to go over to random.org, and there are 7,840 NGC objects. So I'm going to have random.org choose for us a integer between 1 and 7,840. Okay, drum roll, please. 4074. Now, one of the interesting things about the NGC catalog is that it follows right ascension. And what I mean by that is that NGC1 is the smallest right ascension of all the NGCs. So it is very, very, very near 0 hours right ascension. And because of precession, which is another topic that I'm not going to get into right now, it actually may not be any more so close to 0 hours UTC 0 hours right ascension as it once was. When it was first numbered, though, it was definitely the closest to 0 hours right ascension. And NGC 7840 is the closest to 24 hours right ascension. So NGC 4074 is, look, it's sort of right in between those two. So the right ascension of NGC 4074 is going to be around 12 hours UTC. Now, I keep saying UTC, 12 hours right ascension. It's let's see, 7840. Let's pull out, which is always at arm's length. handy dandy calculator, and I'm going to go 7840. Whoops, 7840 divided by 2. So 3920 is halfway in between those two. So 4074 is really, really close to 12 hours RA. So this number doesn't say anything about um, declination, right? Sort of the latitude. It just talks about sort of the longitude. Right ascension is what it's called in the equatorial coordinate system of the sky. So 4074 is pretty close to 12 hours UTC, 12 hours right ascension. So let's go over to Simbad. 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 And we're going to look for NGC 4074 and see what it has to say about that object. I have absolutely no idea. NGC 4074. Oh, all right. So it's a galaxy. It's a Seifert galaxy. And look at the right ascension. It's at 12 hours, 4 minutes, 29.648 seconds. Pretty good. Pretty good. So just sort of, the basic information again. Oh, I think I hear a kitty. Let me go accommodate her request. I will be right back. All right, so as you can see, it is moving away from us at a velocity. Speaking of velocity, Susan, this galaxy is moving away from us at a velocity of 6,705 kilometers per second. That's really screaming. That's really, really screaming. It's also what's known as an S0 galaxy. So the S means it's a spiral, but the 0 means that it doesn't really even have any spiral arms at all. Now in this picture, I'm sort of seeing a dark dust line, and we can mess around with that a little bit, and we can get that uh, on a different viewing thing and sort of dive in a little bit. But these are all the different wavelengths that this galaxy has been observed at. And these are the measurements of its brightness at those wavelengths. And most of these are going um, into the infrared, JHK, UG, RI, and Z. Not all of those. R is visible. U is sort of visible. But as you can see, this is a pretty faint galaxy, at least in the visible wavelengths. We're talking 14th or 15th magnitude. So you would need a telescope about the size that I have at a minimum, and you would need to do a pretty long exposure to get any kind of nice looking image out of it. So pretty faint, pretty small. This is an arc minute, so it's half an arc minute by about a third of an arc minute. So that's pretty small in the sky. Pretty small. Less than 1/100th of a degree in size. So yeah, it's pretty small. Pretty small. But look at all these different names for this galaxy. Look at that. It has like 3 Swift names. Now, why would that have 3 Swift names? I don't know. You'd have to look into the history of the object to dig that kind of information out. But look at that. It's got a bunch of aliases. So a total of 125 references, 83 of them in the past 20 years. So that's not too bad. We can look at the references here in a moment. Look at that. We've got 2 distance measurements. Yay. Let's take a look. So 2 distance measurements. Wow. So each of these are off by more than 3 million parsecs. So one distance measurement is 96.9 million parsecs. The other is 99.25 million parsecs. Which one is right? Nobody knows. That's the data that we have. The data that we have. I guess what I would do is I would go with sort of the newer one. So all good data should have a reference. So this paper theoretically would describe how this number was arrived at. So let's do that. Let's look at this 2011 AppJ paper. Just by clicking on it, we can go to the abstract. Abstract is just a sort of a brief description of whatever uh, work or description of work that this paper is describing. And let's see, can we look at the reference in ADS? Yeah, there's a full paper. Let's look at it in ADS. ADS stands for the Astronomical Data, the Astrophysics Data System. Publisher PDF. Let's look at that. That usually gets us there. I like the PDF files because then we can just plow through these things. See if there's a reference. See if there's a reference to, oh man, what galaxy was this? NGC 4074. So let's take a look. So let's just do a search. Do, oh, here. Oh, that's not it. Oh, Control F. Haha. 4074. Look at that. It's not mentioned. Can you believe that? It's a paper that says that 4074 is in there, and it is not. That actually happens pretty often. Don't really have an explanation for why, unless it's going by a different name, right? Could be going by a different name. So let's go back. This is sort of, what I'm showing you here is pretty much the process that most astronomers have to go through to extract data from all these things. It's just insane what we have to go through just to get data from our colleagues. But that's how it is. So yeah, I mean, it could be any of these other things here. Could be any of these. So I have no idea. ARP, are there ARPs? I don't see any ARPs. MCGs, that's another catalog. MCG, no, I'm not seeing any MCGs. Macarians, NGC, CGCG, KUG. Lots of these weird catalogs. Oh, look at that. There's an MCG there. MCG 429. I thought I saw an MCG 420. No, I saw an MCG 05. Yeah, who knows? Wow, look at them all, though. Random samples of 8 GRI composite images from, okay, yeah, that's just a random smattering of galaxies. We don't know which one is which. Oh, that's very frustrating. That's very frustrating. It's probably listed in the paper somewhere. But yeah, here's some galaxies. These are apparently what are called Seyfert galaxies. Seyfert galaxies. I'm not remembering exactly what characteristics these kinds of galaxies have. Um, Easy enough, to look up. So I encourage you to do so. How about UGC 7064? Is that part of this? UGC, is UGC even listed? No. Yeah, hard to get, hard to correlate data. KAZ 320. I thought I saw KAZs in here. No, I guess I didn't. Yeah, who knows? Who knows? Too hard. Too hard to figure out. Given enough time, I'd be able to figure it out. But yeah. So this is just a population study, just sort of, showing what's what. They looked at a bunch of galaxies, made a number of measurements, and, you know, categorized them in certain ways. And what you end up with are, these populations that are showing these certain characteristics, and then another population of galaxies that are showing um, different characteristics. It's sort of a survey. Um, it points the way. If somebody is interested in galaxies that have, a particular characteristic, then they can go, to this kind of a paper and be like, okay, there it is. Very, very cool. Cheers. All right, well, cool. So that's NGC 4074. Let's go back to Ned, and let's look around the neighborhood a little bit. See what's around. It usually comes up with a. So this is kind of an interesting looking galaxy. Um, this is an image. I think they come up as a default as part of the Digital Sky Survey. Yeah, the Sloan Digital Sky Survey, and this is kind of neat. It's got this like this dark band through it, and it's got this ring around it, and then it's got all these other fuzzies, which are most likely stars. Probably this and probably that are foreground stars that are in our own galaxy. But these things, these extended objects like this, those are other galaxies. Very cool. So I'm going to zoom out a little bit, take its time. Ooh, there's lots of cool galaxies here. This looks like a galaxy. See, see how this thing, this looks like a star, right? It's got those diffraction spikes. See that? So that's sort of what a star looks like. And these diffraction spikes are caused by the optics in the telescope itself. But this doesn't have that. So I would say that that's probably a galaxy, probably an elliptical galaxy. And this seems to me to be maybe even associated with a cluster of galaxies. But wow, there's a lot of cool looking galaxies in this area. So which one was it? Was it this one, which was 4074? I think so. Pretty sure. But look at its neighborhood. Look at this. Look at these. Look at these spiral arms here. Is that cool or what? Look at that. That's awesome. And lots of these other things back here are galaxies too. That's a galaxy. That's a galaxy. That might be. That one definitely is. That's a galaxy. That one. Oh, I don't know what's going on there. A lot of these are foreground stars though. But wow, there's a lot of galaxies in here too. Cool. I saw this one that looks like it's edge on. So most at least spiral galaxies have this characteristic. They're they're like discs. They're like flat discs that have a bulge in the middle and these dust lanes. You see these dark, kind of hard to see. See these dark lanes through here? That supposedly is like dust in that galaxy. Our galaxy has similar things. It has a bulge and it has this disk and it has this dust. So a lot of spiral galaxies sort of look the same. I mean, you know, they're all unique. This also is a spiral galaxy, but we are looking at it sort of face on instead of on its edge. You see, if if we were looking at this galaxy, looking this way, then maybe it would look a lot like that. But we're seeing it on edge, so there's all kinds of orientations that yeah, you know, you just sort of have to deal with. Now, um, um, elliptical galaxies don't have that much of a shape. You can sort of see here, you know, these are just sort of blobs, not a lot of structure, but they do have shapes for sure, and lots of stars, lots and lots of stars. Yeah, that must be part of a cluster or something because it's just, yeah, there just seems to be a concentration of galaxies just in this little area. Oh, there's a few more down here. But, you know, because they're sort of small and big and everything else, probably, probably like this spiral isn't associated with these guys in any way. They're either in front or in back of these large ellipticals. Probably in back because they're smaller, probably. But yeah, it's pretty cool to see all of this. I'm getting into this thing. It's called the Worldwide Telescope, and it's actually very, very similar to this, although it provides a lot of information. So here's another possible little cluster of galaxies. Very, very cool. Very, very cool. All right, what else can we find out about NGC 4074 in this? Let's see, let's go back. So lots of measurements of its brightness. That's good. Number of linked object. I don't know what that means. Figure that out. Plots. Reference. Oh yeah, we were going to look at the rate at the references. Let's display all the references. Infrared view of active galactic nuclei. So Seyfert galaxies must have active nuclei. Because they're talking about active galactic nuclei. But again, a lot of these are going to be surveys and measurements, but not. Here they are looking at the spectra of these galaxies instead of images. Soft gamma rays. Hard X-rays. photometry. Compact groups. Where are compact groups? So yeah, maybe that galaxy NGC 4074 is associated with a group. Looks like maybe so. Yeah, see, here's another reference to galaxy groups. A two-mass catalog. That sort of looks interesting. Should we see if we can find that paper? That kind of looks a little interesting. Go to ADS again. Ka-chung, 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 ka-chunk, ka-chunk, ka-chunk. Publish your PDF. Isn't that awesome? From the comfort of our own home, we can do a deep, deep, deep dive into galaxy clusters. Very cool. A galaxy group catalog. Let's see what the abstract says here. Is built from a sample of the two-mass redshift survey, almost complete, to 91% of the sky. So see, you can sort of see here that we're talking about between 100 million and 10,000 billion stars. That's a lot of stars. Per galaxy. Per galaxy, they're talking 24,000 galaxies in this sort of survey. Numbers just, are staggering. You just have to accept them. I just want to see if they show any pictures of some galaxy clusters. I'm always into the pictures. I don't quite know how to read. Oh, SGL, SGB. This is galactic galactic longitude. Galactic. Ooh, I don't know what SGB is. Bring up here though. Pretty picture. Well, here's some plots of some clusters. I wonder if they actually mention 4074. I doubt it. No. No mention of NGC 4074. May be part of the clusters that they are studying, though. Region around the Centaurus cluster. There's a Centaurus cluster. Two relatively distinct kinematic, which is sort of like how they're moving. Strongly overlapping projection. Blue and red components separated at 4,300 kilometers per second. So what they're saying here is that they're sort of thinking that there are two clusters that we're seeing. Maybe one in the foreground and one in the background. Kind of interesting. Kind of interesting. Here's another way to sort of represent. Okay, so this is representing things in terms of velocity. So this is velocity space, not position space. So how things are moving. So that's an interesting way to look at clusters because, if it's a cluster, maybe they're all sort of moving together. So yeah, that's kind of an interesting way to present. It's all a matter of perspective. And if you can change your perspective, then maybe you can gain some insight into what the hell is going on. I don't know. Sure like looking at these pictures though. Sometimes the pictures are awesome. Lots of tables, lots of numbers. You know, scientists love numbers. Here's some more plots. Again, you know, just looking at different populations. See, so, you know, they're coloring different populations in different ways, just to sort of be able, you know, to separate them out, see what the relationships are. Scientists love to make these kind of plots, though. All right, well, that was it. That was it. I don't think there's anything else there. And this we can go back on. Glad everybody join is joining into this. Hope you're enjoying it. It's you know, you definitely do have to have sort of a passion for these kinds of things. Um, I don't know. Sometimes maybe it can get a little bit dry and boring, but I don't see it that way at all. This is really really cool stuff, and for me at least, it never really gets boring at all. Sometimes it goes way over the head, but I like that too. I like that too. I have you know, I would much rather have things go over my head than, you know, be the kinds of topics that I completely understand and am sort of tired of, right? This is new stuff that is extremely interesting. Definitely not tired of it. See if there's anything else interesting here. Otherwise, I think it might be about time to wind down. Cheers. But as you can see, at least references to this object are numerous. So that's nice. That's nice. You know, sometimes these objects I don't think get the attention that they deserve because they are extraordinary and they are unique in their own way. And each of them has a story to tell, and each of them have, you know, very unique um, characteristics that only they have. And maybe they'll be sort of like other things, but most most things in astronomy, there are, you know, some differences, noticeable ones. And yeah, that makes it extremely interesting, extremely exciting, you know, to study and to find out about. And yeah, each of them have a story to tell. And it's up to us as, you know, the scientists to, you know, to dig into that and build our instruments to make the measurements that we want in order to, you know, to sort of understand uh, better what is going on with these things. Because yeah, it's it's um, definitely mysterious, and I'm glad it is. I hope it'll always be that way. We're always making new discoveries, new you know um, changes in perception, how we look at things, all of that. It's very awesome. All right. Well, I think I'm going to get out of here a couple minutes early, a minute or two early, let you all go. Glad you could stop by. As I said, you know, those who are watching this in the future, glad you could stop by also. Um, take some time out of your day to hear about some astronomical talk for a while. I'm here every single day, 2 hours UTC. I don't see that changing. Um, there's always a possibility that it can, but at the moment, I'm sort of seeing 2 hours UTC as being the time to get together. So check out the Discord channel. There's a link for it down um, in the description below. Um, Yeah, I'm pretty worn out. So I think I'm going to get out of here for now. Glad everybody could come by. I will see you again in almost exactly 23 hours from now. So happy spin. And yeah, I'll see you on the flip side. All right. Take care, everybody. Bye.